Semester 1 review starting at question number 18. Sketch the graph of this equation. Okay, so you have to remember we have a single root at x equals 0. We have a single root at x equals -2. You need to remember that the signs are changing. And you have a double root at x equals +3. You have to remember that at a single root it goes right through. At a double root it goes, it bounces. Here we have 1x, 2x's, 3 4x's. So this is a quartic function. And you need to remember, if it is a minus sign out here and the power is even, does it rise or fall from the left? It rises, utilizing your note card notebook. So I'm going to go right through the -2, right through the 0, up here and bounce off the 3 and down, and there's your answer. Now, any of these problems that we're working and you still need further help, feel free to go back to all of the lengthy podcasts from each note card test review that I've made throughout the year. Number 19 says, if a ball is thrown vertically upward at 45 meters per second, then its approximate height in meters t seconds later is given by this function. H of t equals 45t minus 5t squared. After how many seconds does the ball hit the ground? Now all that stuff could be confusing, but here's what's going on. A ball is thrown up in the air. The path that the ball travels mimics or models this function. How are we going to find how many seconds later does a ball hit the ground? We want to use our calculator. Go to y equals, plug in the function using x for t. Once the function is in, typically with these types of problems, when you hit Zoom 6, the standard viewing window, typically you won't see all of your graph, and we don't. So sometimes you see nothing, and you might want to utilize Zoom 0, which is Zoom Fit, which usually gets most of the graph in the viewing screen, and then from there you would adjust your window to make it better for you. Here I can tell that my parabola is going up and is coming down, and so what I'm going to attempt to do is go to my window and increase my y values to see the parabola better. So if I go to my window, my y maximum is at 10. I'm going to make it maybe 50. And remember, whatever I choose to make it, I can always change it after I look at it if I don't like it. That's still not quite high enough. However, this is only asking me how many seconds is the ball going to hit the ground. I have that answer right here, but I'm still going to go ahead and bring this into view in case you have a problem on your test. You need that part. For instance, finding the maximum or any other questions you might be asked about this type of a problem. So I already set my maximum at 50. I'm going to go a little higher. I'm going to try 125. And that brings my graph into view. I think I have enough room to find this root. I may not. If I start pressing buttons and there's some letters or numbers up here in my way, I may want to change this, but I think I have enough room. When it's asking how many seconds later is the ball going to hit the ground, what it's asking is what's the x value of this root here, or what is the root here? It looks like it's a whole number. It looks like it's at 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like the answer is 9 seconds, but to be sure, I'm going to find the 0. Second, trace, number 2 for 0. That's another word for root. And then I want to take my cursor all the way over to that side, and I need to find the left bound of that root, or that ordered pair, which represents the root. Just get a little close to it. Left bound, hit enter. That's the left side of it, so that's good. Now it's saying right bound. Go a little bit to the right of it, hit enter. Now it's saying guess, hit enter. And I see that it is x equals 9. Is how many seconds later the ball hits the ground. That's the answer for number 19. That's how you work those kinds of problems. You need to be able to manipulate these types of problems within your calculator to find specific answers. Continuing on. Number 20 says some cubic equations have no real roots. I'll let you explore that. 21 says every polynomial equation has at least one real root. I'll let you explore that. Think about what we've done this year. Think about specific examples. 22, the roots of a certain quadratic equation are plus or minus half, 0, and 1 plus I. What this means is this. Basically look to see, is it possible for you to have an imaginary solution here? Okay? Is it possible to have an imaginary solution along with these other solutions? Think about it in that way. 20 through 21, I'm going to let you explore. Use your calculator, look at your note cards. Those are not very difficult. Number 23, we covered this stuff about a month, maybe a month and a half ago. We're going to answer all the questions. We're going to find the points of discontinuity, the X-Intercept, Y-Intercept, vertical asymptote, the whole 9 yards. I do not recall which number this note card was, but here we go. The way we do this is we follow these steps. First thing we want to do is factor the top and the bottom if they're factorable. The first thing I'm going to do in the top is I'm going to pull out a GCF of 4, and I'll have 4 times x squared minus 9, and I have remaining the difference of squares here. So this is going to be 4 times x plus 3, x minus 3. Now to see about the bottom, interesting number that is. Looks like a 2. Okay, we'll go with 2. Hopefully that's it. Okay, so can I factor this? Two numbers that add to negative 2 and multiply to negative 15. How about x minus 5 and x plus 3? And so that makes me feel better because factors are going to cancel. That must be a negative 2. Because negative 5 plus 3 gives me negative 2, and negative 5 times 3 gives me negative 15. If you have no idea what I just did, Mustang factor it. Okay, the next step is, does anything cancel? The answer is yes. So if something cancels, that means I have a hole or a point of discontinuity. And what I do to find the hole, I set the x factor that canceled equal to 0 and solve for x. And I get the x is equal to negative 3. So the x value of the hole is negative 3. Now I must find the y value of the hole. What we want to do now is only use what was left after something canceled. So we have f of x, or y equals 4 times x minus 3 over x minus 5. And to find the y value of the whole, I want to plug in x for negative 3, and I have, negative 3 for x. Y equals 4 times negative 3 minus 3 over negative 3 minus 5. Plugging in negative 3 for x. This gives me 4 times negative 6 over negative 8, which gives me negative 24 over negative 8, which gives me positive 3. So the y value of my hole is positive 3. So I have a hole at negative 3, positive 3. Now to find the x-intercept. To find the x-intercept, we simply take the numerator, set it equal to 0, and solve for x. A couple ways I can do this. I could just set 4 equal to 0 and x minus 3 equal to 0, and 4 equals 0 is not a solution because it doesn't make sense. A lot of you might struggle with that. So let's solve for x the old-fashioned way. Let's distribute the 4. 4x minus 12 equals 0. Add 12 to each side. 4x equals 12, and x is 3. So my x-intercept is 3, or 3 comma 0. To find my y-intercept, I simply plug in a 0 for x and solve for y. So I have y equals, and again I'm going with what I had left here, y equals 4 times 0 minus 3 over 0 minus 5, which gives me 4 times negative 3 over negative 5, which gives me negative 12 over negative 5, which gives me positive 12 fifths. My y-intercept is 0, 12 fifths. Now what this really is, in terms of when you graph it in a minute, it's a little bit bigger than 2. Okay, it's almost 2.5. Alright, continuing on. Vertical asymptote. The way we find our vertical asymptote is by setting the numerator equal to 0. We have x minus 5 equals 0 and x equals 5. So my vertical asymptote is at the vertical line x equals 5. And finally, for the horizontal asymptote, this is where we have to look and see what a, n, b, and d is. A is a number in front of x on top, n is the power of x on top. B is a number in front of x on bottom, d is the power of x on bottom. So for our horizontal asymptote, we have that a is 4 and n is 1. We have that b is 1 and d is 1. So I believe that when n equals d, which we have here, our line is y equals a over b, which is 4 over 1, which is 4. We have a horizontal asymptote at y equals 4. And now we're ready to try to give this graph a shot. See what we can do with it. First thing I'm going to do is I'm going to plot my hole. I've got a negative 3, positive 3 here. There's my hole. I've got an x-intercept at 3, 0. This could be right here. I have a y-intercept at 0 and almost, what is that, 2.4, so almost 2.5. So maybe the y-intercept is right in here somewhere if this is 2. I have a vertical asymptote at x equals 5. So if that's 5, my vertical asymptote is here. And I have a horizontal asymptote at y equals 4. So that is here. Whoa. And then I'm going to give it a shot. Well, it crosses through here and here, and it goes up this way, so I'm going to think it's probably going to do this, never touching the horizontal or the vertical asymptotes. And because of the fact, I'm going to change colors here so you can see it because I have this writing up here, and because of the fact that these graphs tend to have that symmetry, like the parent function y equals 1 over x has, I'm going to bet the other piece is up here, and it goes like that. And that is a review of how to do that. Lots of steps there, but we've done it pretty recently. Make sure you're capable of doing that and finding the specific parts for the exam. Good news is I think the test is almost all multiple choice. Can't guarantee that it all is, but you'll find out soon enough. Alright, continuing on. The artillery problem is basically a quadratic regression. This problem, I'm not going to read the entire thing, talks about shooting artillery. And it tells you where the target is. It tells you where the cannon is, and it tells you another point that the cannonball must go through. In other words, it gives you 3 xy values. You must put those in L1 and L2. And you must find the quadratic regression in your calculator. If you can't remember how to do that, I'm going to refer you back to our earlier regression problems, but here's quick steps. I'm not going to work the whole problem, but I will talk about some steps. First, you will put it in L1 and L2 by going to Stat, Enter. That will bring up your L1, L2. Put those in. You first want to clear your calculator, 2nd plus 7, 1, 2. After you do that, go to Stat, Enter. That brings up L1, L2. Put those points in there. Okay. The next thing that you want to do is you want to adjust your window. Remember that your x minimum is a little bit smaller than your smallest x. Your x maximum is a little bit bigger than your biggest x. Same with your y's. Make your x scale and your y scale equal 0. The next thing you want to do is turn on your scatter plot. Go to y equals. And right above y equals, it has plot 1, plot 2, and 3. Go up there, hit plot 1, hit enter on it and highlight it, and that'll turn on your scatter plot. Hit graph, and there it'll be. How do you write the quadratic equation? You go Stat, Calc, the quadratic regression. And then just answer the questions about the problem. And the rest of it, I'm going to leave you with the last review that I gave you over these logarithms, and that should suffice for the rest of this review. Make sure that you do all of the review and study your best. Good luck.